As we demonstrated, the iterator interface is very simple. It just has a check whether there is a next element. It has a method that makes the iterator move to the next position in the underlying container. And also it has a method to remove the object at which it's currently pointing to, which is returned by the next method. So this is a very restricted type of object in terms of interface. You cannot really use these methods in any other order rather than just saying next or has next first to check the availability, then next to access the element, and remove if you need to be able to remove the element in the middle of your iteration. So why do we use iterators to remove selective elements in our iteration? In the for each construct, there is no direct access to the objects such as iterators, so you cannot remove elements, and therefore if you try to remove element in the middle of for each loop, there will be disruption and there will be an exception thrown in the middle of this. Also sometimes you need to be able to move through multiple collections at the same time. So if you have more than one collection, you can create iterators that correspond to each collection, and you can manipulate their advancement and access to the elements using these iterators. So both of these cases are very typical cases to use, where iterator becomes a very convenient feature available in the library. So as we mentioned, these are the common collection classes. We're going to take a close look at both ArrayList and the map type of collections. And these are so-called concrete implementations. So that concrete means that these are classes, generic classes in the library, which we're supposed to create using the new operator. Once the new object is created, then we can use appropriate interface name to encapsulate the reference and use the reference to access the elements of the collection using methods available in this interface. So we already talked about using names of collections and combining their names with the types of objects that we'd like to create as a combined user type. So list and string or list and integer are examples of such combination. So this is so ability to swap different value types, the types of elements contained within collections, this is what makes them generic. And we say that this is really a generic type of object because it can adapt to any other type except primitive types. Primitive types cannot be used for parameterization, but we have the wrapper classes that we can use to wrap primitive data types inside them, such as integer, right? So instead of using int, we use integer, and you can see that you can still use integers just naturally, like we did with arrays of integers, but when you specify the type, you have to use the wrapper class. Example of a generic class in Java right here is something that you can do on your own. I would say that this is more of a set of advanced programming features in Java, but what we need to do is basically when we declare a class in our Java code, and this will be the name of the class, you can see that the angle bracket with some kind of name inside, like T or E sometimes. It stands for the type. And now we can use this T as the data type inside the definition of the class. This is what makes a class to become a Java generic class. So we have a set of examples. Right here and on this list, we do have an example of generic queue class. So this queue object demo demonstrating a queue generic container similar to this box. So let's take a look at this example. So generic queue here is declared as a class which depends on some type that has to be specified when this queue object is created, and internally is actually using linked list of these objects. But we're trying to implement the queue. So the queue is manipulated through push, which adds element at the head of the list. There is an add first method available with the list, linked list, right here, and we push an item. And so when we write this code, this can be an integer, this can be a string, this could be some other type which will be specified by generic, combined with the generic queue when the object is declared. And there's a pool which returns a reference, and we actually remove the element from the list, and so the list allows to both add first and remove last. So basically we add elements at the top of the queue and remove elements at the back of the queue because we remove the last element from our linked list. We also can report whether the queue has any elements so that there is a size method available. So here this is a generic queue driver program right here. So that what we do is we create generic queue of strings, for example. So then we add elements to this queue. Okay, and notice that we use the new operator and we specify string right here. So we create this object, and we can basically demonstrate the pulling from the queue is by simply printing these strings by iterating through a list of objects inside our queue. So the queue is named Q1. So this is an example of how you can both define a generic class in Java and how you can use it. There's also a rectangle class with which we also do some demonstrations right here, and this is what gets printed as a result of executing this demo code. So this statement creates an array list of type string. So we're actually moving towards examples using ArrayList because there's still interesting examples to demonstrate. And of course, just to remember that integer data type, int, the primitive data type, you cannot use with the generic classes in Java, so you have to use the wrappers like an integer class. And this is just another example of linked list that uses some sort of product class to create a list of products. Okay, so starting with Java 1.7 JDK, this diamond shape that we used in our sample becomes available. So in my main method, when I create collections, I use this diamond syntax to have compiler derive the actual data type for the type of list from the declaration of the actual reference to this list object. And so this is again just a demonstration of this syntax. Alright, so in general, when a class uses generic types, it's not limited to only one generic type. Basically, you can have more than one type specified, and we use angle brackets like this, and there's just a list of types that we list right here. So here we can have string, comma, something else, if we had a generic Java class that used more than one generic parameter in its class declaration. Now remember that that declaration looks like this. So here this X, the generic type that we use in this example, there could be comma and more of these types provided for the so-called generic types combined with this generic Q class. In our examples later on, we will have map objects which actually do require the key type, the key generic type, and the value generic type. So that's going to be demonstrated a little bit later on. So we talked about the generic Q, and again, this is the idea that generic types can be specified with the class combined with the name of the class using angle brackets right here and using some kind of generic name in the middle, and then inside the body of this class you can start using it as a data type. So when you're constructing ArrayList, it's possible to use an empty parentheses, which we did right here, and this creates here in this example right here down with the ArrayList example, this creates an empty list object. But if you'd like to reserve space for a certain number of values, you can just specify capacity to begin with. For example, specify that you want an array list and you are anticipating to use a certain number of elements, like for instance 100 elements right here. So when you do something like this, it really is not going to change anything, but the array list is going to be created with space reserved for as many as 100 elements, and the constructor of ArrayList will calculate how to organize internal memory or memory structures to accommodate 100 elements. Reserving these elements actually does not create 100 elements. It's only reserving the space for them. So if I wanted to verify that, I can print the size of our numeric codes array list right here. Okay, if I try to print the size, okay, there's a size method right here which returns the size, and we can say numeric codes size is, and just print it all together with the result of the size. If I run it, you see that the size as a result of me adding two integers to this list is 2. So only 2 of these were added. However, the capacity will be derived from the requested number of elements.